All right, thanks for joining us. I am Joseph. I come to you from California State Parks, and we are today at one of 280 state parks in California, Seacliff State Beach. As you can see, we're not alone here today. We get over 1 million visitors a year here at Seacliff, highly popular spot on Monterey Bay on the central coast of California, and the only place in California where you've got a rotten, broken, sunken concrete ship offshore. Those who tuned in before know that I don't just work here at Seacliff. I've worked at many of California's 280 state parks. But one place, and I've worked at some national parks too, but one place I've never worked is the Grand Canyon National Park in Arizona. And those that are in California right now, even here on the coast, you know that 2020 just keeps breaking all the rules. It's a crazy year. It's so hot here. Even on the coast, it's pretty hot. And that's not what we pay astronomical rent to live. Yes, it's so hot here. It kind of feels like Arizona. We mentioned Arizona a couple weeks ago when we talked about migration. There's another national park there called Petrified Forest. I think it's technically a national monument. And it's full of redwoods, which don't grow anywhere near Arizona now. But that shows us how forests can migrate. Even though a tree spends its whole life in one place, forests do migrate over time. And the only place you find redwoods now is on the north half of the California coast, and a tiny little bit of Oregon. So just like Petrified Forest and Grand Canyon National Parks in Arizona teach us a lot, we have something out here in the middle of Monterey Bay that teaches us a whole lot. And it's in the middle of another protected area called the Monterey Bay National Marine Sanctuary. Last week, we talked about California state marine protected areas, and there are a few around the Grand Canyon of Monterey. So if you've heard of the Grand Canyon, I'm sure even those tuning in from Illinois and England have heard of the Grand Canyon. I've never been there, but it's a big hole in the ground in the desert in Arizona. And you'll see there's a river at the bottom of it called the Colorado River that carved that canyon, sorry. What we're going to see about this one is the more we explore the Grand Canyon of Monterey Bay, the more we realize just how much we have to learn about our planet. So let's talk about canyons, grand and otherwise. I'd like to show you this Grand Canyon we've been talking about. And while I am flipping screens and all that, I do like to check in on questions. All right, sounds like Brian's with us again. Good. All right, so let's flip you around. Oh no, let's show you what I have queued up for you. I've got a number of things because if we're going to explore a submarine canyon from the Seacliff Visitor Center, we're going to have to get pretty creative. Did you bring your imaginations today? If not, you're lucky. I keep extra imagination behind my back, and I can send it through the internet to you. So if you need a little extra imagination, here it comes. And then you've got to turn it on. I turn on my imagination using my right ear. I don't know how yours works. Only you know how it works. So find a way to turn on your imagination. All right, that's going to be a big help today. You're probably going to have to leave it on the whole time. So we're going to take the next. Do you see me sweating? I'm not kidding about how hot it is in here. We're going to spend the next 30 minutes or so. Today might be a little shorter than some of the other ones. I say that a lot. We'll see what actually happens. But Monterey Canyon's formation tells us a lot about what California might have looked like millions of years ago. And then to even map and explore and get to know this canyon, before we can even learn anything about it, we have to learn how to get down there, and we have to create tools to collect data so that we can learn anything about what's down there. So just to get there, we have to learn a bunch of stuff and develop new technologies. They're called robots, rovers, sampling machines, you name it. So it's really only been in my lifetime. I'm about to turn 40 in November. It's really all the stuff that we know about Monterey Submarine Canyon has really come along in my lifetime. And most, I think, of what we know about it has come along just since you've been born. This is all new stuff, and we're learning more all the time. And one thing we'll see today is just how much we don't know. All right, so let's show you the Grand Canyon. So we're going to share content just for comparison, so you know what we're talking about. So I'm going to bring that up. I've got a few websites to poke around on here. So here, I just brought up a bunch of images of the Grand Canyon in Arizona to give you an idea how big and majestic it is and just the kind of power that a river has to shape the land. And I think my favorite image of the ones I could find was this one right here. I would show it to you a little bit bigger, but it takes us to a website, then a bunch of pop-up windows come up and all that. So just, that's going to have to be big enough for now. I like this one because it shows you got a really good look at the river. That's called the Colorado River. It's like one of the biggest rivers west of the Rocky Mountains, but it mostly flows through desert. And it's this life-giving ribbon of water that goes through the desert. And you can see all the green around the river there, just how life, plant life really concentrates on the water in the middle of the desert. So it gives life to the desert, but also this image shows you how it gives shape to the desert. The reason you've got that great big hole in the ground is as that water flows and flows, and you can even see some rapids down near the bottom, it's carrying away bits of rock with it. Sometimes more than others, when it's flooding and really charging hard, it can carry boulders downstream. But most of the time, it's just bringing bits of sand and clay downstream with it. But over millions of years, that really adds up. And what it makes in the case of the Colorado River and the Colorado Desert is a Grand Canyon. So there's that. Now, we have a river flowing around here called the Salinas River. Pretty important locally. We grow a lot of stuff using the water from this river. It's called the Salinas River. And you see one of our images at the top there. It's kind of one of the major rivers on the central part of California, but it's not anything like the Colorado River. If you look at this image, there's barely any water in it. Much of the Salinas River flows very slowly underground. The actual river itself, John Steinbeck, a famous local author from around, who was kind of living and working around the same time as our friend Julia Platt, who we talked about with marine protected areas last week. He called the Salinas River kind of a part-time river. It only really had a lot of water in it some of the time, and it's nothing like the Colorado, but this is the river that empties into the Grand Canyon of Monterey Bay. So there's a mystery here. Why do we have such a Grand Canyon? Here's what it looks like with some of the mapping that's been done. Why do we have such a Grand Canyon when we have such a kind of part-time river flowing into it? We're only just beginning to understand this, but look at this. This shows us just how the Monterey Bay, or the canyon under Monterey Bay, stacks up next to the Grand Canyon. It's just as deep, but at the far end of Monterey Canyon, it's under a Grand Canyon worth of ocean. So you want to talk about big holes in the ground? Well, the Monterey Canyon is so big it keeps going down under the water. But you see the sheer cliffside on the Monterey Canyon. It's got some steeper cliffs even than the Grand Canyon. So something truly extraordinary, and we're really only just beginning to understand it. So go ahead and chime in if you've been to the Grand Canyon before. A person who's tuning in, as far as I know, for the first time today says, I've gone camping so I could stay and walk around the Grand Canyon. So some of you have been there before, even though you're not anywhere near 40 years old. I've never been there. I've only seen it from an airplane. Even from an airplane, it was really quite impressive. All right, so do chime in here and there. I wish we could kind of just, talk and talk. All right. How did the Grand Canyon get so big? Asked one of our other new people, Amel. So remember what we said. You got to think about the power of a river, and you've got to think about time. So if you give a river millions of years to carve away, because that's what water does, it takes away little bits of rock kind of all the time when it's flowing by. You can see this if you go to a beach. and the tide's going out, you watch where the water goes, you'll see it pulling sand with it everywhere it goes. That's kind of geology in fast motion. We'll give a big river to the desert a few million years, and it's going to, when it's flooding, it will take entire boulders downstream. But if it's just taking sand and stuff over enough time, it digs a big hole. And that can happen even underwater, as we're about to see. So good question. I don't always see hands when they come up, but I do check in pretty much every time I flip the screen around. So great. Let's take a quick walk through the visitor center. Hello again. And get to know Monterey's canyon. We're going to do this a little more low tech. I like it this way. All right. Okay. If you look behind me, you'll see. There we go. Probing the depths. That's what we'll be doing today. All right. So there's a map of kind of the central California coast up there. If you were way high up in a plane or maybe even a satellite and look down at us, that's us. This is what you would see on the California coast, although I'm afraid it's not very green right now. It's really, it's hot and humid, but in California, it rained yesterday, which is so weird. And we had thunderstorms. We had more lightning than we had rain, and so we had a bunch of fires start, including one very near the Salinas River and near the town of Salinas. So it's a little bit smoky out here. There was ash on my car this morning. Wild. So here's the middle of California's coast, the central coast of California. Monterey Bay, as we've described it before, kind of that big bite out of the central coast of California. The canyon comes out at the mouth of the Salinas River. And the Salinas River is a very long river, even if it doesn't have a lot of water in it. It would go off this map. But it comes out in the middle of Monterey Bay. So now that you've seen it from really high above, let's probe the depths. Let's go down into Monterey Canyon. Look at this. Wow. All right. A little bit of perspective on this. Let's see. I've got to move it differently than I think I do. Okay, so for perspective. Hello again. I'm going to go to the other side. Nah, I don't like it over here. I'm going to go back to the other side. There we go. All right. So even though you can't see me yet, I'm here. We're looking at the north end of Monterey Bay. I want to do that because that's where we are. So, do you see that light up at the top? So here at Seacliff, you can see that the ocean is somewhat shallow as you go out from the beach, but not for long. Some places, this seabed where it's not really that far underwater, just off the beaches, it's called the continental shelf. Sometimes continental shelves can be really wide. You got to go really far out to find deep water. Not around Monterey Bay. And this is one of the things that makes this such a great spot for research. We can get to the deep sea really easily from land because you can drive to the head of the canyon in a town called Moss Landing. Elkhorn Slough comes out here, and that and the mouth of the Salinas River are both right here, and they come out through here. And look what they do. Just keep carving down, down, down under the thing. Now remember, there's a bit of a mystery here. The Salinas River is not a big, mighty, powerful river like the Colorado River, but it has a canyon just as grand. We'll have to ask ourselves, how do we get to that? The thing is, like our dig into fossils showed us a few weeks ago, our dive into the canyon gives us an idea of what California might have looked like millions of years ago. But let's get to know the canyon a little bit just by poking around and looking at the lights. So if you're with us last week, we talked about our marine protected areas. You don't have to go far off Seacliff to find one. If you remember us talking about Soquel Canyon, there it is. Soquel Canyon is kind of a side part, a small part of Monterey Canyon, but it alone is as deep as the Santa Cruz Mountains are high. And the mountains around here, I mean, we're not talking about like, snow-capped Mount Everest mountains, but they're pretty big and they're pretty steep, coming up over, 4,000 feet out of the ocean. This canyon is as deep as those, and then it just keeps going down in Monterey Canyon. We're talking we're talking miles below the ocean surface. So let's see, there's anything else I wanted to show you here. I think we got the idea. All right. But there's even more of it. It doesn't even fit on the screen. Here's the Monterey end of it. And you see another major side canyon right there. You see that? Is that lighting up where we can see it? Not really. Okay. Right here. Carmel Canyon is another very impressive canyon that empties down into the Monterey Canyon. So we've got some rivers that contributed to an even bigger river that carved this huge canyon underwater, but none of the rivers around here are really that big. So how do we make sense of this? There's another look right there. There's a satellite image. You can see it in the canyon in some satellite images now. We're at the top of that image. All right. So how is it that a kind of ho-hum river can carve such a mighty canyon? We got to look way back in time to figure that out. So I don't know if anybody, I think Brian, maybe a couple of you were with us when we looked at our fossils here, because Seacliff State Beach right now is the seashore. But you go back a couple million years, we were the sea floor. So this is kind of a funny place, so I'll have to get in kind of a funny position to show you. But you might have remembered seeing these maps when we looked at fossils. All right. And yes, it's hot here. Okay. So the California coast now, you've seen it before. It kind of looks like this. This is probably a better color representation. We are kind of reaching the blonde time of year when we haven't had a lot of rain. Okay. So San Francisco Bay, Monterey Bay, and we have something called the San Andreas Fault, which is kind of a weak point in the shell called crust around the Earth, below the inside of the Earth. The hard crust that we live on has cracks in it, and parts of it move on the kind of almost lava-like stuff underneath, what's called a mantle. And so this side of the San Andreas Fault, every time we have an earthquake, it might only move a little bit. Maybe we have a big earthquake and it moves, 20 feet or, about, maybe even 10 meters in a jump. Every earthquake moves the ocean floor and the part of the land that's connected to it up past San Francisco to our north. So we've got some major movement going on the California coast. Give earthquakes a few million years, and they can really change the look of a place. And if you look at what the fossils tell us, because we found fossils in places like Bakersfield and Coalinga and Fresno, ocean fossils, 100 miles from the ocean. That tells us that the mountains that we have on the coast now, big as they are, probably weren't even here millions of years ago. And the ocean came well inland and flooded much of what is now part of the Central Valley. So this fault that we see here might be telling us something as well. Remember, we looked at the Colorado River, which made such a grand canyon, still making a grand canyon in Arizona. It's thought that the Monterey Canyon that we have is, again, a few million years old. It was here before the coastal mountains were. And it's thought we must have had a bigger river that came out in Southern California, further down the San Andreas Fault. A bigger river must come out around what is now Santa Barbara, we think, which has got big old mountains in it, so maybe those weren't there either. But there was a big river that came out down that way. And then the canyon was carved by that bigger river. But then earthquakes over time moved the canyon up to where it was just off our part of the coast. So even underwater, the earth is moving. So it moved up to our part of the coast, where the Salinas River then connected to it and found it. So if you look at the sediment, it's called, somebody asked, how do these rivers make these canyons? Well, the rock that they carry with them as they flow, whether it's just little bits of clay and sand or big old boulders or parts of cliffs that fall in it, that's called sediment. The sediment that we find kind of on top of when we get to the canyon and we just find the first stuff sitting at, we go to the bottom, but that first dirt we hit, that's coming from the Salinas River. The Salinas River emptied into this bigger canyon that a different river had carved before. And one of the best guesses, and it's just a guess right now, it's a hypothesis, one of the most interesting guesses, maybe the Colorado River, the same one that carved the Grand Canyon that we know of on land today. Maybe that same river carved the Monterey Canyon a few million years ago. It's only the best guess. There are a number of other equally good, what we call plausible, that makes sense, let's try to find out, ideas of how this canyon might have formed, but we don't really know. It had to have been a river, and it must have moved with the earthquakes, as we said. But we don't know which river, and we can't find out until we can go really deep underwater and start digging really deep into that deep ocean floor. We got to get past the Salinas River sediments, which are sitting on the top there at the bottom, until we can get down to find out what kind of rocks are under the Salinas River sediments. That might tell us which river it was that carved the canyon in the first place. So how do we get down there? Well, I'm going to get off my knees and go somewhere more comfortable for that. We have to study this, we have to develop some new technologies, as we were saying. So let's have a look at what some of those technologies look like. And let's go somewhere more comfortable for your friend Joseph at Seacliff State Beach to stand. Let's see, what have you been talking about? So our friend in England knows that California is called the Golden State. So yes, the yellow color, I think, is an appropriate one to use on maps. And then your grandmother used to say the brown hills are golden. Yes. That's kind of a matter of opinion. I hear some people like brown, their hills get all brown and dry in the late summer. Some people are like, no, it's beautiful, they're golden. Right? That's what your grandmother said. I kind of take a middle route, and I say that the hills in California, the dry hills in California, are blonde. There's definitely a beauty to blonde, but it's not quite as loaded as golden or as, mundane as brown. Now, I say that as a brown-haired person, right? I think brown can be beautiful, but yeah, golden sounds really majestic. I go with blonde when I talk about California's hills in the summer. And I see a hand from, I think, Anessa. Hi there. Go ahead and just ask your questions. I don't usually get to hands. I don't really know what to do with them. So I'm not that good with these iPad things. How do earthquakes make the ground shake? That's a good question. So I guess the way I would put that is the ground that we stand on, as solid as it seems, and it feels like it's in the same place to us every day. Remember, we're on a planet that's spinning and spinning. You are moving hundreds of miles per hour right now, even if you were just wishing you could catch a breeze here in California. But the ground we're on is moving. It's kind of floating in a sense. If you start going below the rocky ground that we live on, underneath it it's not quite a liquid. I've heard it described as plastic. So it's really hot, kind of like magma. What comes out of volcanoes is lava. It's part of the earth inside called the mantle. And the rock that we stand on kind of floats along on top of it or scoots along on top of it, but it's not a very neat process because all the edges of the different parts that are moving bump and scrape and move up against each other. And sometimes you get, like, let's say this is Northern California's ocean and this is the Northern California's, what are now the mountains now. Sometimes the ocean parts go underneath and they melt and then they bubble up over here, and we call those the Cascade volcanoes. So there's a whole other program that we can get into, but how do earthquakes make the ground shake? They're moving. Parts of the earth that we're standing on are moving under our feet along the mantle, but they're so tightly stuck together that as they scrape by each other, they rub on each other and they push each other up and they push each other down and they move side to side. And that is what we feel in what we call an earthquake. I have felt a few, but I've never had anything terrible happen to me because of one. I would love for that to remain true. But we have to remember, as destructive as earthquakes can be, they're the reason that California looks the way it does. So, good question. All right, so we were going to go take a deep dive, hopefully cool off a bit. Let's share our screen again. Okay. And see how we even can see what's under Monterey Bay. Let's have you. All right, so remember, this is just how deep our Monterey Canyon is. There's a couple of ways of knowing. To get under the ocean, you gotta use robots. And so as weird as some of what you're seeing here looks like, I would love to spend more time on this, but we're gonna have to kind of zip along before we go too long. So sometimes you hear people talk about knowing more about outer space than we do about what's under our oceans. And studying the two, you have to deal with some of the same challenges. So the Monterey Accelerated Research System, based right here on Monterey's Canyon, the abbreviation for that is MARS. So there's a cable that runs from the middle of Monterey Bay out to the canyon under the ocean. I don't know how they do this. They must have used boats and robots is my guess. But we have cables like this, and we've had them for a while. I mean, we're talking to a friend in England right now. You could do that even when I was a kid. You could call people in Hawaii because people had laid cables under the ocean for us to call through. Now we have other ways. We beam it through space. But cables are still handy. If you've got a cable, the robots that we send out there, if they're not attached to a cable, they have to have their own batteries, which can take up space and weigh a lot. And they have to store their own data on them. So, and if you lose them, all that data is gone. So one nice thing about having a cabled observatory is that all the batteries, all the power, and all the data, the stuff that we've learned and that we're collecting, we can do that on land where it's safer and easier and we have more room for all that stuff. And then you just attach these funny little instruments to the end of the cable, and they can attach up to 8, and then they can attach other experiments to those 8. So you can have a lot of different experiments going on at once under the ocean using the Monterey Accelerated Research System, or MARS. But you can't do everything attached to a cable. So let's have a look. So we have what are called remote operated vehicles. These, believe it or not, do still have cables on them, but you can take them out on boats and then launch them deep into the canyon. They have 2 that they use at a place called the Monterey Bay Aquarium Research Institute. I've been using a lot of their information today and a lot of their resources to show you what it's like out there. They are right at the end of Monterey Canyon where it meets land. So they have 2 machines they use. One is called the ventana, which is the Spanish word for most things in California have a Spanish name. The Spanish word ventana means window. So it's a window into the deep. And then they have another robot called the Doc Ricketts. Doc Ricketts was one of those people, not quite 100 years ago, in towns of Monterey and Pacific Grove that really had a really strong interest in the science behind our oceans. So they named this remote operated vehicle after him. So they take them out, they have cables attached to them, but they drop them down from the boats. And this is what they look like in action. So let's tune in. All right, so there's the Doc Ricketts, and let's watch the Doc Ricketts as it fills the ventana, and the ventana films it right back. How do you get pictures of robots underwater? You have them take pictures of each other. So there's the ventana and the Doc Ricketts. So this is the Doc Ricketts looking at the ventana. There they are looking at each other. You notice they do have cables on top of them. So they have to have 2 different ships out there at once, 2 remote operated vehicles, and a whole lot of cable to get them down there to take film or shoot video of each other. That's what they're doing. So look at that robot arm out there reaching out to collect something. Sometimes the things come to you. That's called a sleeper shark. We know we have those in SoCal Canyon Marine Protected Area. And there it is, visiting wherever they are in Monterey Canyon now. As alien as some of the animals under the ocean look to us. Oh, ROV fist bump. Clearly they are friends. As weird as some of these animals look to us, imagine how weird that robot must look to them. Some vehicles can travel on their own. So an autonomous underwater vehicle, it's not remote operated, it's an autonomous underwater vehicle, means we have to program them, they have to carry their own data, they have to carry their own batteries, but they travel on their own through the water without being attached to a cable or a ship. They have other types of rovers. In Elkhorn Slough, they have some things that just sit in one place and collect data, and I kayak right by them. I wonder if I've influenced their studies at all. Here's what that cable observatory that we saw a drawing of earlier. Here's what it actually looks like. Look how big it is. So here's one of the ones that sits in one place and collects data. If you go kayaking in Elkhorn Slough, which I love to do, I live right down there, and it's just kind of where that canyon goes inland. You see an amazing variety of wildlife, and they use these things to study what's going on in the water there. And so you'll see little things sticking up, and that's deep ocean research in action. So what do they find when they go down there? Let's have a look.
The goal of the Monterey Bay Aquarium Research Institute is to bring scientists and engineers together to develop new tools for studying the deep ocean. Right off the beach here in Monterey Bay, we have the Monterey Submarine Canyon, and it gives scientists access to the deep ocean right off our shore, like the scientists don't have the opportunity to do anywhere else in the world. My name is Stephanie Bush, and I am collaborating with the Monterey Bay Aquarium to collect deep-sea squids and octopuses for their new exhibit. Today we're on the Rachel Carson, and I'm the chief scientist, which means that I run the main camera and hopefully find us some animals. I'm really interested in studying the deep sea because it is the largest habitat on Earth, and yet it's really difficult to get to, so it's been studied very little.
Good catch.
I'm really excited to be able to show these animals to the public. They're weird, and I think the public is gonna love them.
And that right there is my favorite exhibit they've ever had at the Monterey Bay Aquarium. And I think the woman in this video, the one who's narrating for us, I think she brought her daughter to one of our in-person class visits. They came with their school last year before we all had to make sure we did our distance learning instead. So look at that. You see there that big red jelly, the fang-toothed fish. These are animals we only really learned about by diving deep, and only just in the past few years. They've seen this animal fewer than 10 times, and the only reason we know is because we've been sending those remote operated vehicles down. Look at that. I have a quote from one of the other scientists at the Monterey Bay Aquarium Research Institute that tells us just how much we still really have to learn about our planet. It says, every time we dive below 2,000 meters, we see species that are new to science. To put that another way, every time we go to the bottom of the canyon, we see something that humans have literally never seen before that shares this planet with us. Look at that. So we're doing some pretty important work down there, and we are learning some amazing things, but also some kind of alarming things. Just this morning, I wanted to find out, so what was the most recently discovered species in the ocean? And it was just in March, back before the pandemic hit here in California. What is the most recent animal or species that's been found on these dives? There it is. It's called Erythrines plasticus. So here's an animal we've never seen before. We've never seen this animal before. But that name, plasticus, by the time we found it with our eyes and our scientists trying to learn things, our plastic pollution had already found it. This animal that nobody had seen until earlier this year already had little bits of plastic in its body from plastic that we used and threw away that ended up in the ocean. So, as big as the ocean seems, as little as we know about it, we are already affecting it with what we do on land at home. It's not just us. There's a certain amount of, we can be careful with the plastics we use. We also got to talk to our governments and our big businesses about how they do that. We all have something to contribute, and it's our choice whether we contribute to plastic and deep sea organisms or we become part of the solution to that problem. All right, let's stop sharing that screen. I can't think of a better segue, as they call it, into our Junior Ranger Pledge. Are you back with me? You are. So we always end our Junior Ranger webinars with a pledge. This is part of what makes you a Junior Ranger. It's not just knowing this stuff. It's going out and learning more and finding out what you can do about it. So we're going to make a promise, not just to learn things, but to do a better job of living on this planet. So there's a big piece of junk in the ocean there. That one worked out a little better because it's not made of plastic. But the way we're going to do our Junior Ranger Pledge, and some of you have heard this before, so bear with me. I will say something, and then you will say that back to me with one important exception. The first thing I say when I need you to repeat after me will be, I state your name. But don't say that. I would say, I, Joseph Carr Ritchie. That's my name. But you will say, I, Anessa Lamb, or whatever your name is. Okay. Winnie, I, Winnie. I, Tim, IML. And then repeat everything else just as I say it. But even more important than saying it is doing it. That's what makes you a Junior Ranger. All right. So, repeat after me. I state your name. Promise to treat the earth and all living things with care and respect. Be careful of what I do and how it affects others. And learn about the importance of nature and our heritage. So think about how what you do affects other people. Think about how it affects oceans at the bottom, or animals at the bottom of Monterey's Grand Submarine Canyon. The more we learn about the place, the more we learn just how little we know about our planet, what we already know. We've got work to do to save that canyon and the life in it, and ourselves. So that about wraps things up. Let's check in with your questions if you have any, and then we'll call it a day. So can people go down there in a mini submarine? It could be done. I can tell you that much. Brian is asking this from London. I forget the name of a vehicle, but people have been to the deepest point in the ocean, which is called Challenger Deep. And it's on the other side of the Pacific Ocean, kind of near the Philippines. There's a spot called the Marianas Trench, which is the deepest part of the ocean. And the deepest part of Marianas Trench is called Challenger Deep. And yeah, very recently, an astronaut went down there because she wanted to, she'd been to space, she wanted to go to the bottom of the ocean as well. So you can take a submarine down there. look at sometime on your own, look at what water pressure does to things under there. So the kind of engineering we had to do to make a submarine that can do that is extraordinary. But people have been to the deepest parts of the ocean. Now, they weren't outside in a scuba suit. They were in a submarine. If they were outside in a scuba suit, their bodies would literally be crushed. So they had, you got to be in a submarine. And then Yvonne was saying, I can't see you. All I see is your shared screen. Well, hopefully that is no longer the case. But yeah, that's kind of how I am able to show you around the bottom of Monterey Submarine Canyon. As much as I would like to dive in today, I'm not equipped. I don't have a submarine. I don't even have my wetsuit. So I wish you all cooler weather, comfortable conditions, and a very marvelous Monday. I hope to see you next week when we talk about Lonely Hills in Monterey Bay. Bye for now. Thanks for tuning in, Junior Rangers.